Statistics, Unit 1, Lesson 3. How many hours do you work a week? Today we're going to be discussing the shape of a graph and making dot plots. Okay, what we did in class today is I asked everybody, how many hours do you work a week? And so they went ahead and recorded it on the board, and then we made a dot plot out of it. So a dot plot just is equally spaced numbers, and then the data filled all the way up. So each dot represents a student in my class that worked that certain number of hours a week. This one here is this student worked 15 hours a week on average. So you can push this button and you can open up the applet and you can make a dot plot yourself, or you can do this one by hand. You can also make a dot plot on your calculator, which I'm going to demonstrate. So I'm going to use this here. And this I'm going to call dot. So the first thing you're going to have to do, I should have shown you right in the beginning, is from your home screen, you're going to go to New Document. New Document is right there on number 1 on your calculator. Then you're going to go to List and Spreadsheet, which is this green one right here. Okay, it brings up a blank spreadsheet. I have mine, has some data already in it. Go ahead and put your data in there, and then you're going to go ahead and label the data. I'm going to label mine dots with lots of S's just because I want to. So I have all my data right here, and this is data different than this data here. I already have this graphed, but I'm just going to show you how to graph it. So once you have the data in here and it labeled, you go to Control, and then Doc, and list data and statistics. You're going to tap here and go to dots, and there's your dot plot. Okay, so go ahead and create the dot plot. But then what we're going to do is I went to this website here, and this website has tons of data for all kinds of different questions. And the question that I looked up was the question that asked how many students on average work, or how many hours students do on average work in Texas. So I compared our data to Texas data, and this is what I got. So if I ask you to describe the similarities, the word that we're going to be using, or the acronym we're going to be using to describe similarities, is CUS. C stands for center, U stands for unusual features. We describe gaps and outliers. S stands for shape, and the second S stands for spread. So we're going to go ahead and look at the shape, center of variability, and outliers of this. The shape, so remember C is CUS, the center. So if I look at the center, I would say, my median. So I'd look at the center of it, and it looks like if I have how many dots I have, 50 here. And so there's 50 dot plots, and it looks like my center is actually here at 0, because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I guess not quite. 20, 21, 22, 23, 24, 25. How many do I have here? It doesn't seem like 50. 26, 27, 28, 29, 30, 31, 32, 33. Actually, no, I have 34. So the 17th piece of data, which is, I believe, what's right back down here, which is at 0, these are at 0. This is at 1 hour, and this is at 2 hour. I apologize. So at 2, that's going to be my data, where it looks like about, on average, the median is about 2. And it looks like this one is 1, 2, 3, 4, 5. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's going to be my 6th piece of data, which is going to be right here. So about 1. So ours, the median is about 1 hour per week is what people work in my class. And about 2 hours per week is the median about what all the students do in Texas. So I'm just looking for the median, the middle number, or half below and half above. So if I look for the shape, my shape is going to be, if you notice, this just goes all the way towards the right. It's not symmetric, so we call that skewed to the right. It's leaning, being pulled, the outlier is pulling it to the right. Same with this one, it has a less skew, but it's definitely, because of this outlier, if you laid a blanket over it, it's going to blanket, and then drop off, and that's going to be skewed to the right. The centers, we said, were right around this is about 2 hours a week, and this is about 1 hour a week, because it looks like that's the middle number, the median. the variability, this one goes from 25 minus 0 is 25 hours a week. And the range for this one is 40 minus 0, which is 40 hours a week. And the outliers, I haven't given you the rule yet for the outliers, but you just say, hey, it looks like 40 is really unusual and it's definitely far out than most everybody else. These might be outliers as well, and 25 might be an outlier. So anything that's far away from the data could be an outlier. Main things that you need to be learning from this lesson is to make a dot plot. You can write this down, but what I like to tell you on a dot plot is title, label, label, tick, tick, tick. Let me explain what I mean. Title, label, label, tick, tick, tick is that you're going to want to make a title. And so we've already have our title in here within it, but my title would be dot plot or dot plot of workers in period 4. Label, I'm going to label the x-axis here, number of hours worked. I label my y-axis if I have one, dot plots I don't need one, which would maybe be my frequency. And I label, I tick marks, which is 0, 5, 10, 15, 20. And I have tick marks on the y-axis if I need it. But you need to make sure you have a title, a label, x-axis, label, y-axis, and tick marks on both. Skewed left looks like this, where it's leaning to the left, where everything's leaning to the left, kind of, leaning to our pizza, going down, sloping down to the left. Skewed right is sloping down to the right. And symmetric, everything's about the same on both sides. And we're going to put fairly symmetric, doesn't have to be perfect. When I compare the distributions, I'm using the acronym CUS. C stands for center, U stands for unusual features, which is gaps and outliers, S stands for shape, and the other S stands for your spread, which is your variability, how spread out it is. So check for understanding. We're going to be comparing Stony Brook and Millbrook. If I ask what 12 in Stony Brook graph represents, I look at 12 and I see here and I look, okay, 12 means that the dot above 12 represents one place in Stony Brook that was sampled that had a nitrate concentration level of 12 milligrams per liter. What percent of the nitrate concentration measurements for each stream exceeded 10 milligrams? So for Stony Brook, I look and above 10 is just these two. And there's a total of 42. So 2 divided by 42 is 0.048. Similarly, for Millbrook, there was 11 of them above 10. And then that's divided by 42 and is 0.262 or 26.2%. As far as rounding, usually 1 or 2 decimal places is totally fine. There's not any set rule for rounding. So if you do 1 or 2 decimal places, you're always set. Describe the shapes of the 2 dot plots. Well, if I put a sheet over the Stony Brook one, you can see that the distribution is a little bit skewed to the right. And because you can see it kind of leans to the right or, slope to the right. And if you see the other one for Millbrook, you can see if I put a line over top of it or a sheet over top of it, it's pretty symmetric. When you could compare the centers, the nitrate concentration for Stony Brook tend to be lower. The median's 5 milligrams and Millbrook is 8 milligrams. And the way you do that is you're just going to find the center dot. So if there's 42, then your center dot is going to be right above the 21st dot. And compare the 2 centers. Is the variability the same or different? And it's different. Variability, remember, we're going to do the range, which is the highest, which is 12 minus the lowest, 0. And this one, the highest is 20 minus the lowest, which is 0. So Stony Brook is 12 milligrams and Millbrook is 20. Thank you for listening, and I'll see you guys next time.